Good morning. Welcome everyone to our webinar. This is the fourth in a series of webinars dedicated to high performance computing, or HPC, that we are organizing for newcomers to introduce you to what it is and what you could do with supercomputers. By we, I mean Lux Innovation in partnership with the Lux Provide and the University of Luxembourg. Allow me to introduce myself for those of you who don't know me yet. My name is Ramona Caula and I'm working at Lux Innovation, the Luxembourg Innovation Agency. And today I'm not the only one on the stage. Here with me there is Luis Vela from Lux Provide. Luis, would you like to introduce yourself briefly?
Absolutely. Thank you, Ramona. Hello, everybody. Like Ramona said, I'm Luis Vela. I work for Lux Provide as a senior solutions engineer. And at Lux Provide, we don't only manage the access to the Meluxina supercomputer in Luxembourg, but we also kind of try to bridge the gap between HPC, artificial intelligence, and all the companies in on the neighboring regions who wants to take advantage of these technologies.
Thank you, Luis. We'd like this webinar to be really interactive, much interactive as possible. So please don't hesitate to use the webinar toolbox on the right side of your screen. There is the chat box where I invite you to introduce yourself, to share your contacts so that you can link with other participants with this webinar. Then there is the questions tab where I invite you to type in your questions about the content. So the question you'd like Luis and I to answer at the end of the session in the Q&A session that we will have after his presentation. And we have also a poll. We appreciate you if you'd like to answer the questions we prepared for you so that we can adapt our speech and our next session to what are your needs. So let's see together the questions so you can answer. The first one is, do you use artificial intelligence in your daily work? Yes or no? Or do you foresee the need of using AI in the future? If yes, in 1 year, in 3 years, in 5 years, or maybe you don't know yet. Then the third one is, do you foresee the need of a supercomputer for training your AI algorithms? Yes, no, or maybe you don't know yet. I invite you to answer the questions, and this helps us a lot also foreseeing for the next webinars that we prepare for you. I'll come back to see the responses of your questions to see what's the result. But now let's see what's HPC Thursdays. So HPC Thursdays is basically we wanted to give you some information about what is a supercomputer, how does it work, what are the components, the elements, what you can do with it. So mainly HPC use cases, examples to inspire you to use a supercomputer to boost your innovation capacity and capabilities. So as you see, we are halfway the program we foreseen for you. Today, we're going to see the artificial intelligence and data analytics on a supercomputer. But I invite you to have a look at the next ones. So we'll have the next session on 17th of March with HPC for health, presenting a use case scenario or use case example. Then HPC for finance, and in April we have also HPC for digital history and public administration, where we have some speakers presenting how they use supercomputer in their activities and why HPC was so important for their work. Last session on the 5th of May will be more on discovering Meluxina. So you will see the presentation of Lux Provide about Meluxina and this unique infrastructure and their support services that are also open to businesses. You see the pop-up for registering to the next session, so don't hesitate to do that. But let's dive into today's session with our guest speaker, Luis, who will give us an overview of what you can do on a supercomputer using artificial intelligence and data analytics. Thank you, Luis, for accepting to speak today, and I'll give the floor to you.
Thank you, Ramona. First of all, it's always a pleasure to contribute to the HPC Thursdays and to work with Lux Innovation. You guys do a fantastic job. Let me share my presentation. I should have it around here. Okay. Can you see it, Ramona?
Yes, it's working.
All right. Fantastic. So yeah, welcome everybody to HPC Thursday. In particular, this session about artificial intelligence. This is the logo of my company, Lux Provide, and as I mentioned, we are the company who is managing the access to the supercomputer that the government recently acquired and inaugurated last year. You probably heard everything about the supercomputer already in the previous talks, specifically the one from the 17th of February from my colleague Alban Rousset. And if you were in that talk, you might recognize a few of the slides. But let me go straight into what I want to talk to you today about, which is you hear a lot about artificial intelligence, but perhaps it's a good first step to go really from scratch and try to understand what intelligence is, because that's really the requisite to understand what artificial intelligence is. If we know what intelligence is, then we know what we need to replicate a version of intelligence that machines have. And once we know that, we go to the third point, which is how can we leverage this technology? And obviously, you all have heard about artificial intelligence in the media. And this is a whole ecosystem of methods, technologies, expertise, hardware, software. It's really in depth. The amount of time that we would need to go really in depth in this topic, it's really, it could be a PhD easily or several. So I'm not going to do that. What I'm going to do instead is present you with 3 interesting examples where artificial intelligence together with a very powerful computer in the back can create really big impact on businesses. And for that purpose, I have chosen to talk about a little bit about predictive maintenance, natural language models, and reduced order models. So very interesting examples that are kind of close to my heart, and I'm sure you're going to like it. So let's begin. What is intelligence? If we really type this into Google, it's going to tell you it is the ability to acquire and apply knowledge and skills. So you're going to acquire knowledge and skills, but you're going to acquire from where? So the idea is that there is a world, there's a place where you can experience, that you can know, and from there you draw or you acquire knowledge and skills. But intelligence is not only acquiring them, but only applying it back into this world. It's a very short definition for such a complex concept, but it's very useful because it gives us a working something to work with. It's easy to extrapolate to artificial intelligence from here. If we see artificial intelligence, for example, it basically means intelligence demonstrated by machines. It could also be not only machines as opposed to, let's say, animals or humans. And then when we speak of artificial intelligence, we don't have the world itself. We have like a model of the world, which we can interact and derive. Instead of knowledge and skills, we can derive data and relations between the data. And not only deriving them, but also using them to act upon this simplified world model that we can think of. So how can we actually artificially replicate intelligence? Is it really this simple? Is it really a matter of gathering data and relations between data? For the moment, let's assume it is as simple as this. I'll get back to this question in the future, but let's assume it's as simple as being able to gather data from the world and learning relations between the data collected and then applying it back. What about data? Well, we're lucky because the estimates say that if we are not already drowning in an abundance of data, we'll certainly be in the future. The trend is exponential. The amount of data that we as a civilization are producing, it increases at exponential rates. And they have give reason to fields like big data, data analytics, and artificial intelligence. And perhaps the places where it's expected to come at huge volumes is, different spheres of different types of technologies, different types of interesting futures that we envision for our cities, for our cars, for our personal devices, things like that. So I don't think there's going to be a shortage of data anytime soon. Whether the data that we're interested in is properly labeled, properly structured, and things, that's a different question. But raw data, it will be there for us. That's not an issue. What about relations? What do we have in our toolbox to learn relations between the data that we gather from the world? Well, this is a very interesting sunburst chart of different methods, both belonging to machine learning and deep learning, which are kind of our shorthand terms for all the different methods that mathematicians, statisticians have come up to learn relations between the data. So there's a myriad, there's a big set of these methods, depending on the specific type of data that you have, depending on the specific type of relation that you want to learn, you can choose. And I'm not going to go through all of them because first of all, it's not an exhaustive list. And second of all, each single subset here would take, like I said, several perhaps hours to introduce and to explain and to make sure that you guys have a working understanding of it. So that's not really the idea here. But rest assured that the amount of methods for learning relations between data exists. And if you at your company hire the right person, very likely they're going to come with most or some of these tools on their repertoire to help you and your company learn these relations. What do I mean by these relations between data? What I mean is that you will find in the world a lot of pairs of data, basically an input and an output. What corresponds, in this particular example, on the left, we have an image, which is a kind of data, an image of a car, and the output, which is a word, is also kind of data. And the map or the relations between these two is if the image contains what your eye would identify as a car, then the word accompanying that should be car. If the image does not contain a car, then the word that should be related to that should be not car, or some other object that you think it should be inside there. So these relations between inputs and output is exactly what we want to learn. It's a relation. You could say it's a function. You could say it's a map, but let's call it relation for the time being. And there are two different really sets of this kind of methods for finding relations, machine learning and deep learning. Briefly summarized, and this is an oversimplification, and most of you know more about this topic than me, but machine learning includes, it gives the possibility for humans to help or to have a prior stage in the construction of the relation where we, with our expertise, already filter and massage the data and extract new features from the data manually before we send it to the machine. While in deep learning, that human part is, for the most part, avoided, and the machine takes over from the beginning. The machine really learns everything from scratch. It can take longer, it can need more amounts of data, but both of them are very valid approaches depending on really on the end result that you expect to have. So with this, I want to say that first, the amount of methods that we have at our disposals for learning relations is vast. And second of all, the main concept behind learning a relations is having an input and an output and a correct answer that we can tell the machine what it is. This is a subset of artificial intelligence called supervised learning, but it's the one that is mostly the one that is widely used right now. So let's go back to the question of whether that was a simplification of what artificial intelligence is. Is it really just data and relations and nothing else? Or there's something else they're hitting? something that that will, if we don't include this something else, this unknown, we will never really truly achieve artificial intelligence. And that really depends. It's an open question. Nobody knows the answer to it. If you ask around, you will see that Meta, what used to be called Facebook, wants to make an AI that thinks like human. And that means it's not just a simple world where you acquire data and you acquire relations between the data and you apply it back. It's slightly more complex. You have a world which you can perceive and you can act upon. But inside of the AI, there's a world model. It's a small simplification, a small simplified but useful version of the real world. It has short-term memory. It has a cost, intrinsic cost, and critic creator. It has a configurator and so on. So you see, the concept is one thing, but what we actually do as humans, or what actually happens inside of our brain, it can actually sometimes be more than just data and relations. For the time being, we're going to stick to data and relations because it works really well for a lot of businesses. But just keep in mind, this is an open question. All right, with that introduction, let me see how can we turn the art of acquiring data and learning relations between the data into something useful for us. So first of all, I would like to talk about predictive maintenance, what it is and how it's related to the concept of artificial intelligence that I mentioned, and what can you expect from it. Well, predictive maintenance is basically a smart way of doing maintenance of the equipment that you have at your factory or at home or at your office or things like that. And the first or the most intuitive way of doing maintenance is let's not fix it until it breaks. So if it breaks, then you fix it. Is there a better way of doing that? Because if it really breaks, then repairing it from scratch, if one component really breaks and explodes, let's say, it can also damage the adjacent components. If you would have repaired before it explodes, then you only have to replace one part, but because it exploded, it not only you need to repair that, but all the adjacent components. So the reactive approach might not be the most economical to you. There's also a downtime while it's being repaired that the machine is really not usable by you or anybody. So then you have the preventive maintenance, which what it does is you set up an interval, let's say every 30 days, and every 30 days you go and perform maintenance on that machine and make sure it doesn't break. If the interval is too short, then it's almost guaranteed that you're never gonna let a defect evolve to the point that it's going to break the machine, but it's expensive because it's very often. And if it's too long, then it's cheaper. If it's instead of 30 days, it's every year, then it's cheaper because it's only once a year. But the risk of one of the machines going into failure, it's bigger. So it's you have to compensate. You have to choose this interval very carefully. But we can do better. With artificial intelligence, what you can do is based on the data of a lot of machines, of what circumstances were they before and right after they fail, you can learn what are the signs that start to appear and before they fail, and how far away the failure is from the first signs. For example, if your engine starts making noises, it can still work, but the noise is already telling you that perhaps 2.5 months are left for the engine. But if you see smoke coming out, that's a much stronger sign that it's about to fail, and perhaps you don't have another 20 kilometers to go. You should really stop your car and call, somebody to help you right away. With predictive maintenance, we can use all these examples from the past and know or predict when is it going to break and adjust accordingly. We see signs, we act upon that. We read data, we learn the relations between the data, between the signals and the time to failure, and we can act back into the world by saying, hey, you have 5 days in 5 days, it would be a good idea if you go and perform maintenance on this machine. And beyond that is prescriptive. For example, okay, so your car, it's starting to show signs of failure. And our predictive maintenance says that you have 50 kilometers to go. However, prescriptive maintenance would not only tell you that, would also give you alternatives. It says, why don't you shift to first gear and go at 10 kilometers per hour? That's not going to give you 50 kilometers range. That's going to give you 500. right? Because you put less pressure on the engine, less pressure on the mechanisms inside, and even though it's defective and it's prone to fail, the failure, you can prolong it until you reach a pump or something like that, or a mechanic. So prescriptive not only tells you very carefully when it's going to fail, like predictive does, but also gives you options on how to avoid it, how to make the best of the limited time that you have. Another way of visualizing this is reactive maintenance. You see here an axis X and Y. In the X axis, you have time. On the Y axis, you have machine health. If it goes to 0, it means it fails. And reactive maintenance, it basically waits until it fails to perform maintenance. Preventive maintenance, you choose an interval upon which you go and maintain the machine. But if it's too short, then you still have some usable condition that you're not really exploiting. And if you go too far beyond that, then you're just doing reactive again. And predictive maintenance is the cheapest because you optimally choose the interval for maintenance. So that's really, really good. And it can be done, again, by taking data from historical events of failure, learning the relations between these events, and applying back to your machine in question. So how does it work? Well, you choose a frequency, let's say 30 days, let's say a month, let's say every day. You determine what are you going to be monitoring, the noises in the engine. You're going to be monitoring the heat. You're going to be monitoring whether there's a smoke coming out. And you have a predictive model that tells you if the last control was a month ago, and if the temperature of the engine is very high, even though we have only been running it for 30 minutes, then it's very likely that something is wrong. Or the opposite, it might take these 3 variables and conclude that it's okay, it's fine. That's the normal way in which this engine performs. So the initial predictive model is very important. And how do you construct this predictive model? If the amount of data is very big, to construct this predictive model or to learn the relationship, that's what it means, you could use a very big computer, and Meluxine is one such computer. So what do? Every now and then you keep monitoring the condition. Every hour you check the engine. It's still okay, it's still okay, it's still okay, it's still okay. Does it need attention? If it doesn't need attention, you just keep doing it. But if it does need attention, then what you could do is issue a report, create a work order, and perform maintenance. If it needs attention, it's like, hey, I saw a crack on the main axis of the engine. I'm going to call the car dealership and tell them that we're going to be there on Monday morning. That's it. But you can do something else, which is you can use this new data to enhance or give feedback to the initial predictive model. You can keep on learning as you go from new mistakes, from new data points, from new scenarios. And that can also be done through the use of Meluxine. If you are a car manufacturer and have 1,000 cars on the road, each of them giving you new data points, when it's right, when it's wrong, you can get this data and add it to the bag of historical data and train again and come up with a better predictive model over and over again. That is about predictive maintenance. It's a very interesting topic. Artificial intelligence is at the center of it, and as you can see, it can give really interesting benefits for any company. Let me see another interesting example, which is natural language models. It's basically using artificial intelligence to give the machines the appearance that they understand what we're saying when we write or when we speak or when we draw, actually. How does it work? Well, what you could do, I took this from the GPT-3 website. GPT-3 is a very, very famous language model. It's a big bag of numbers and weights and biases, numbers, let's call them, that can be used to predict the next word in a sentence. It's as simple as that. So the first thing when you're constructing a language model, like you mentioned GPT-3, what you do is you have to train it. It's untrained, that's the gray box. And once you pass it through extensive and massive data sets, like 300 billion tokens of text, then what comes out is this shiny, colorful GPT-3 version of itself, which is a trained model. And now this shiny version can predict what comes in the lower part, which is a robot must what. Then the gray part has no idea what's the next word, but the shiny model, which has been trained, it has a very good idea of what is next. So what do you do with it? How does it become shiny? What you do is you let the untrained guy predict. So he predicts a robot must, and he predicts exterminate, Terminator-like scenarios. And you say like, no, hold on, it should be obey. And then you send back this as an error, as a correction to be updated, to learn. And little by little, by telling him what is right and what is wrong, he will eventually learn this relationship. At the end, you have this GPT-3 model who has been trained on millions and millions of textbooks and articles out there, and you can download it and use it for your specific purpose by doing something which is called fine tuning, which basically, instead of just giving it sentences that have to do with robots, imagine your business has to do with treating clients, then instead of giving it a robot mass, then you tell GPT-3 to learn sentences of the type or of the sort of, good morning, sir, how can I? And then GPT-3 is going to take this new set of text, which is specific for your business. It's much smaller than the big one that took for the original training, and it will become fine-tuned for your specific purpose. We're going to see some examples of this in a minute. But this is what I'm talking about. So you have a lot of data in the form of text, images, speech, structured data, or even signals. And by training it, you get a foundation model. That's a big model that let's call it good for everything. But if you really want to make it specifically good for a specific task, then you need this fine tuning. And so a big language model can be good for question answering if after the main training, you fine tune it into question answering text. You can fine tune it to sentiment analysis. After the big training, you pass it, this comment sounds nice, this comment is offensive, this comment is bad. This review is a 5-star review, this review is a 1-star review, things like that. Information extraction. This long text can be summarized with these few phrases. Image caption. This image can be described with these 3-4 words. I mean, an image of a sunset, then please use GPT-3. Whenever you see this image, write down it is a sunset on the east coast of the Aegean Sea or something like that. So the data. So where do we get these tons of data that these models use? As an example, let me use here 4 important models: BERT, Roberta, Megatron, and Megatron 11B. Let's talk about Megatron LM, which is the one that NVIDIA trained. Not too long ago, it was on the news. And you could see here the corpus of things that it trained on. The yellow part, it's real news. It's a lot of news that exists online. All this news can just be used as training material. You have open web text. That's the red part with a little icon. Those are Reddit links. Reddit is this huge platform where people speak and express their opinions. And if you send your model to learn from all the text written in those forums, that's a big chunk of information you can use. You also have, what's this, the dark green, Common Crawl Stories. You have Whole of English Wikipedia, which you might think is a lot, but you see how little in its head it actually corresponds to with respect to the other sources of information, and a book corpus of a lot of digitalized books. So use this data to train it. You have the foundation model. Now, how do you fine tune it? You fine tune it, like I told you, given a specific text for your task. And the results can be very impressive. For example, you can here tell GPT-3 not only to speak, but to speak like Elon Musk. So you type who I want the teacher to be, you type Elon Musk, and what do you want to learn? You want to learn, teach me about relativity. And it will reply with the style and tone of Elon Musk. If you ask what kind of rockets do you build at SpaceX, then the machine will tell you SpaceX builds 2 types of rockets, Falcon 9 and Falcon Heavy, and plans to build a rocket called BFR. Very interesting. Imagine making your chatbot sounds like Sean Connery. That wouldn't be bad. Let me see something else. This is very interesting and very useful for what's called a no-code approach. You have a database and you want to calculate the revenue of the users, and all this information needs to be queried through an SQL command, but you don't know how to code on SQL. GPT-3 can transform what you want into SQL, which can later be used to fetch the information. So how much revenue did we have in each of the last 2 months? Question mark. And GPT-3 will create this select, sum, and so on, this SQL query that you just copy paste and you retrieve the exact result that you want. Extremely useful, extremely useful. Next example, this is one of my favorite. You type what you want to see on an image. Generate a front-facing young black, what is it? Generate a front-facing young black adult female with brown eyes and long hair. Generate. It understands what it means, the text, and it looks for images that fit on the description, which is absolutely mind-blowing. And this is also an application of GPT-3. It's very impressive, but time is pressing. So let me move to the last example, which is reduced order models. Perhaps the first two are really well known, but the last one is not so well known, but extremely, extremely important for many applications. Let me tell you what it is. First, let me reuse some of the slides from 2 weeks ago from Alban. You probably saw something similar on his presentation. This is a snapshot of a laptop computer trying to simulate the wind patterns or the wind flow around the Philharmonie building in Luxembourg. For those of you who have gone to Kirchberg by car or by tram, you've seen it on your right. It's quite a beautiful building, emblematic, and we wanted to check how the wind will flow around its columns, around its roof, to make sure how comfortable would it be for pedestrians to walk around the building. If there's some specific parts of the building that are very prone to creating vortices that could, mess up your hair or whatever, or move the pages on the book that you're reading, then we would be able to identify it, and we perhaps can think better of how to design this building in the future. However, if you use your laptop, this is the kind of resolution that you can afford. If you really want to make a long enough resolution in time, the detail, it's really, really bad. If you increase the resolution to get something decent, your laptop gets fried. It's too intense, this amount of detail for your laptop. So what do? Well, you use a supercomputer to put extremely high detail to get a very detailed simulation of the wind, of the shape of the bursts of wind, and things like that. So you can really evaluate with great precision the pedestrian comfort index. But this is something interesting. In your laptop, this cannot run. In Meluxina, it can run, and it takes, let's say, 1 hour to run the simulation. 4 hours, let's call it. So from initial condition, let's say initial condition is, let's simulate wind blowing from the south around the Philharmonie. What's the result? What is the wind rate of change at the north part of the Philharmonie? And this is the result. And it takes about 4 hours. Well, you can use artificial intelligence to map that initial condition to the same or slightly or very good approximation of the same results in much less time. This model would be an artificial intelligence model that can be trained to map this initial condition into this result, and it would be a fraction of the time. But how you do that? Well, actually, you have to pay a cost. The cost of training this model is making a lot of these Meluxina simulations. So on the blue box, you have many initial conditions: wind blowing from the south, wind blowing from the north, with high and low speed, wind flowing from the east. Oh my God, a new initial condition. And each one of them, you make a proper detailed physical simulation in Meluxina. Each one of them is 4 hours, right? And with that data, you train the model. It's very lengthy because each one of these is 4 hours and you have many of those. But the catch is that you only have to do it once. So you construct this model once, and the model is so fast that it can run on your laptop. So now if we go back to the original loop, the left and the right loop, on the right, you have Meluxina. You use a supercomputer. It takes 4 hours every time you want a new result. Every time you want a result for a new initial condition. But with this model, it will take a fraction of your time a fraction of that time to get the same result from that initial condition. The price to pay is that at some point at the beginning of the year, you have to train a very big model with a lot of data, but it's worth it. This is an example. This is precisely the wind around the Philharmonie using a very detailed HPC, a very detailed physical simulation. We will see later a video. It took about 4 hours, like I mentioned before, and this is the patterns of the wind at the end of the simulation. Took about 4 hours in Meluxina, a single simulation. if I instead spend some time training a model, making sure the model is good, and then I use the model on my laptop, I can get very similar results, identical for all practical purposes, in a time of 4 seconds in my laptop. This is a huge speed up. Not to mention that you do it in your laptop. So it's very interesting. That's what reduced order models are. So if you are in the prototyping industry, if you are in the simulation of new manufacturer techniques, reduced order models is something that you guys should really look into. Even if the model, the trained model, can run in your laptop, remember that there's a price to pay at the beginning with a lot of fine simulations to train the model, and that's what Meluxina is perfect for. I'll show you this video because it's not just one snapshot. The result is not just a single snapshot. It's an evolution of the wind. I'll show you that at the end. And the last example that is very, very interesting for me, it's this one. These guys at Monolith wanted to evaluate the stress on the blades of the wind turbines by changing different parameters on the blade construction. So you have parameters Z1 to Z7. And if you modify them, then in principle, you would have to run a whole physical simulation that might take hours to come up with the real stress on the blade. But because you have trained a model already, these guys did it with 600 simulations, then you can simply choose a new combination of Z1, Z2, Z3, Z4, and get the result almost immediately, almost real time. It's very, very interesting for prototyping. So with that, and before I come into the Q&A, let me really quick share with you, let me see, where are we? Let me really quick share with you a video, a YouTube video, where we show, the comparison between an HPC run simulation and a reduced order model. So on the right, let me first stop it. So here on the right, let's close this. Can I close it? No. So on the right, on the left, you have upper and lower part, HPC run simulations. And on the right, you have the AI evolution of the same system, but in a fraction of a time. You see that the main features of the flow are very, very identical. There are discrepancies, of course, but hopefully they will be negligible for every important application. The resolution can be increased. We can talk about the details of it, but so far the results are very impressive, especially taking into account that the speed up was 3,600. So that's the evolution of the flow. The wind stabilizes, and by the end, you see that the patterns are really, really similar. One took 4 hours, the other one took 4 seconds. It's a little bit wiggly, but you see that the magnitude of the speed field it's spot on. So with that, I would like to finish the presentation. Thank you, everybody. I hope it was interesting. I'll be happy to reply to any questions you might have.
Thank you, Luis. That was exciting to see what you can do with high performance computing and to analyze data, to train your AI models. And I invite everyone here attending to type your questions. If you have any questions for Luis and for me at the end, we will answer them. So don't hesitate to put your questions in the questions tab. Before going to see them and going into this Q&A session, I would like to invite you to answer to the poll, and let's see what you answered so far. So for the questions, do you use artificial intelligence in your daily work? We see that around 60% of you are not using it. But if you are here, maybe you will be inspired to use it in the future. Do you foresee the need of using AI in the future? So I see 50% of you don't know yet. So this is, again, the place to be to understand if it's a good option or a good path for you in the future. And do you foresee the need of supercomputer for training your AI algorithms? Maybe don't know yet. It's the majority of you answered. So I think we have another question that should be released in the poll. And this is asking how difficult it is for you to it was for you to understand and to follow the information that was provided during today's session. So if it was too basic and you already knew everything, or it was easy to understand and useful information were shared, it was a bit challenging, but still you got the main point, or it was too complicated and you struggled to understand. This helps us for the next sessions to adapt and see how to shape our presentations so that it answers your needs. Now I would like to briefly introduce you to the Luxembourg National Competence Center in High Performance Computing and how we can help you to dive or approach the HPC world, supercomputing world. So I will keep it short, so we'll have more time for your questions. The National Competence Center actually is a support for industry, doesn't matter the size. So it could be startup, SME, or large industry, for academia, so researchers, and also for public administration. What we do, actually in Luxembourg, we are the contact point to guide you through the HPC ecosystem at the national level, but also at the European level. So at the European level, we are a part of an international network of competence center in HPC, and we have the chance to collaborate with other national competence centers to help you and respond to your needs the best possible way. But let's focus on Luxembourg. What are the companies, or what are the actors behind the National Competence Center? So there is the Lux Innovation, the National Innovation Agency. We support companies to innovate today to be ready for tomorrow. And there is also Lux Provide, the company managing Meluxina, the national supercomputer. Their focus is mainly on industry, and they support, they offer tailored support to HPC users. And the University of Luxembourg is also part of the National Competence Center. They offer education, they have academic excellence, research excellence. Lux Provide is also offering some trainings and workshops. So if you are interested, that could happen for you also, specifically for you, with tailored workshops and hands-on trainings for your company. So we have the supercomputers of the University of Luxembourg and Meluxina, the National Supercomputing Center. But what we would like to offer is not just the access to the HPC resources, but we'd like to build an ecosystem to ensure that these resources are well used. So we offer you operational support, hands-on support to help you to access and make the best use of supercomputers available in the country. We offer you the possibility to explore the financial support that is available if you'd like to set up your research projects or innovation projects. And we put you in contact also with other initiatives at the national level or European level that could make sense in your case, and you could take advantage of them. Let's see what exactly are the services we provide. So we help you identify the opportunities where HPC could be used and applied to your activities, being business or research. We help you to explore funding opportunities and or to find a partner for if you'd like to establish or to set up a research and development and innovation project. With the help of Lux Provide and the university, of course, they offer the possibility to set up a feasibility study or a proof of concept, so for you to explore what could be done for your specific case. We offer access to HPC resources and IT support at all levels in case you are a newcomer to HPC and you haven't used it yet. We encourage HPC users to become independent, so that's why I offer skills development trainings, training courses in HPC, either by the university or Lux provide with hands-on labs, so that you could try to use it to see by yourself how it works. And we offer also a customer and domain-specific workshop in case you have a nice group of people at your company and you'd like to organize a workshop for them to understand and learn how to use HPC. We can do that as well for you specifically. Thanks to our European outreach and the fact that we are part of the network of National Competence Center at the European level, as I mentioned before, we can reach out for international collaborations if you'd like international partners or you're searching for going beyond Luxembourg. And we also put you in contact with the right people and other HPC initiatives that could help you to better develop your idea, your project, your innovation. So Lux Innovation is your single point of contact. If you have any questions and you'd like to set up a meeting, don't hesitate to contact me. Yeah, here maybe I will share my contact details. And as I mentioned before, we are here to support you to understand what a supercomputer is, what you can do with one, and how to take advantage at its best for your success of your business or your research boost. Well, I guess now we are ready for the Q&A session.
Yeah, I see a very interesting question here on the not on the chat, but on the question panel from Johannes Kner. Sorry if I mispronounce your last name. So how do you ensure that your response surface modeling ROM actually covers the parametric space that you want to explore later on? That's a very, very good question. That's very good. What happened here? That's a very good question. Oh, sorry. Yeah, I see that.
It's me saying everyone that we are answering this question for now.
So strictly speaking, you cannot. But that's basically saying if you have a cloud of points, imagine a two-dimensional problem with a cloud of points that you want to pass, you want to fit it with some function of certain degrees of freedom. You come up with the best possible curve, you fit it, and then you tell me like how accurate is going to be the future predictions. If you want to know the value of a data point that falls inside of the parameters of that cloud point, then I think the approximation is going to be really good. However, if you fit it on an interval here, but you want to make a prediction over there, very far away, you might control the stiffness of the curve in this area, but you don't know. It might explode exponentially or something like that, and you might be in for a very nasty surprise. However, reduced order models have something very interesting, which is a part where you identify the dynamics of the system. Basically, the model learns physics. I don't tell the wind how to move when it finds higher pressure on the left than in this right. It will actually move to the right. I don't tell it to follow all this Newton first law or second law or third law of dynamics. It learns it on itself. And even though that's out of my hand, what I can do is ensure that certain behaviors are, certain physically meaningless behaviors are avoided. For example, I can avoid situations where no matter where in the space or parameters you are, the energy is never going to explode, either exponentially or logarithmically or nothing like that. Energy is always going to be bounded. So that's always a good sign. It's not a perfect sign. It's not energy conservation. It's not global conservation. It's not microscopic conservation. But it is, at least it's bounded. So that's at least going to rule out very, very physically impossible scenarios. I hope that answers somehow your question.
Thank you, Luis. I invite you, if you have any other questions, to type them in the questions tab. Maybe in the meanwhile, I have a question for you. When is a company should come to you if they would like to approach or build an AI system? So when is the moment they should come to you?
That's a very good question, because I think that the examples I chose give the impression that Meluxina and LuxProvide are here whenever your AI needs are huge and you are facing a big bottleneck regarding the computational power of your of whatever laptop or whatever workstation you have at home or in the office. And so you might be discouraged to come and try supercomputing for you. But the truth is that we not only work with HPC ready partners, we want to work with people who want to become HPC ready partners. So even if your workflows are small, you can already take a lot of advantage by using Meluxina, not by using full Meluxina. You can use a little part of Meluxina, which in and of itself, it's already a lot more powerful than a regular computer. You can, for example, come to our CPU nodes, use a single node, which has 128 cores. That's a lot more than your regular laptop. If that's already something that you're doing and you want something else, come to our GPU cores, GPU nodes, where we have 4 GPU A100 NVIDIA cards ready for you to use them. They're connected with NVLink, no overhead, and that's already a huge, massive step forward. If you want farther than that, then you are already by yourself starting to fiddle with HPC. And so that's already our strong point. But the beginning, the starting steps, the exploring better and faster possibilities for your workflows, we're also there for you. You see, it's not only offering access to a better machine. Sometimes the way you use a powerful machine is very different from the way you use a normal machine, a laptop. And the example that sometimes I like to use is, you think that because you bought a machine that is twice as expensive, or you rented Meluxina, which is 2 or 3 or 4 or 5 times more expensive than the machine that you're currently using, a fraction of Meluxina. Therefore, your results should be 5 times faster or an equivalent amount. And that is, if you don't know how to use a big machine, that's never going to happen. And we're there to help you. And the example that I have in mind is, even if one woman if it takes one woman 9 months to deliver a baby, you cannot expect 9 women to deliver a baby in 1 month, right? There are certain things that you cannot simply by art of magic expect them to be faster. That's not going to happen. So come to us. We'll take a look together at your code. We'll make sure that you are ready to start thinking in parallel. You start thinking in optimization terms. And once that is the case, then you can scale up to full Meluxina use, which is, you will be one of the big players out there.
Yeah, well, nice to see. We have another question, actually, as a follow-up of your last question.
Yeah.
So in the end, I still need to have a rather complete physical understanding of the problem beforehand. In layman's terms, is this basically an interpolation of previous CFD calculations?
In layman terms, that is exactly what it is. It's a way to interpolate between previous simulations without having to run the full simulation on your own. You have this model that is able to run it for you, for you in a fraction of the time, deliver very accurate results, and you can use it to, if you have a cloud of points with actual data points with actual physical simulations, you can fill in the gaps between them really, really easily. You can explore the whole parametric space when you're prototyping really fast, really easily, and that's going to speed up your process. Now, whether you really require a complete understanding of the physical problem or a complete physical understanding of the problem beforehand, that's not necessarily the case. Many of the softwares for CFD are already, to a big extent, black boxes that you don't really need to know anything else apart from, should I increase the Reynolds numbers? Should I put friction? Should I put viscosity? What viscosity? You don't need to deal with that in our model. You give us the raw data, the raw output data, no physics. What I meant about the energy being bounded, it's something that you can enforce when the model looks for solutions that don't diverge in time, but no physical understanding needed.
Great, thank you. So, are there any other questions we'd like Luis to answer, given that he is so good at answering your question and explaining clearly what is AI, supercomputer, and also to understand how to translate all these complicated terms into easy to understand things for you. So for now, we don't have any other questions. I don't know if you would like to say anything else, Luis, or to encourage people.
Feel free to contact Ramona in order to get in touch with me or me directly at Lux Provide. We're happy to take your inquiries, even if you want to have a test of Meluxina, if you want us to have a quick look at your code, how you can improve, what are the opportunities for you, feel free to do it. We're open for business.
Great, thank you. So let me conclude in this case. I invite you to register for the next webinar. We'll have a presentation about a health use case on the 17th of March. So please join us, register to the next one. We'll be happy to inspire furthermore you to use HPC for your innovation and to boost your activities. I thank you, Luis, for this nice presentation. For me, it was really inspiring, really exciting to see what you can do with AI and the supercomputers. So don't hesitate to contact us, and we are happy to set up a meeting with you to discuss your particular situation, your particular ideas, and to tailor our solution to your needs. Thank you again for being today with us, and hope to see you for the next session. Thank you again, Luis, for being with us today.
Bye, everybody.